All right, this is going to be the last video for Note 67. In the first video, I did a refresher on evaluating functions. In video 2, I started talking about these composite functions. And question number 3, we had a numeric evaluation. And question number 4, we had a numeric evaluation as well. Question number 5, we're going to start getting into composite functions, but they're not numeric. And so what I mean by this is when you look at part A over here, right? We've got f of g of x. There's no number here, okay? But here's the idea. You have a g of x function, you have an f of x function, okay? So we got the two functions. And what I want to start with is exactly the same thing as if it was numeric. I'm going to start on the inside here, and I'm going to figure out what g of x is. Well, g of x is equal to x minus 4. So simple substitution tells me that I can do f of x minus 4. That's what g of x is equal to. And now this is what I'm evaluating, okay? And this is where I'm going to try and keep the function over here. So here's my function, f of x, right? And wherever I have an x, I'm going to replace it with x minus 4, okay? So this is going to equal, I got x squared, plus, whoops, that's supposed to be plus 2, and I'm going to slide over here to x, and then plus 3. And each of these spaces for x is going to take on that x minus 4 expression. And this is actually then very similar to something that happened in video 1. I think it was like question number 2, part C, where basically I just want to simplify this side of the problem. Right? So f of x minus 4 is equal to this mess over here. And let's simplify this. So x minus 4 squared, I'm going to rewrite that as x minus 4 times x minus 4. This way, remember, fully distribute, okay? But I can at this point go ahead and distribute 2 here to the next set of parentheses. So that's going to be positive 2x, right? And then 2 times negative 4 is going to be minus 8 plus 3. There's an equal sign here. And then I'm going to go ahead and fully distribute x minus 4 times x minus 4. All right. If you like doing little arc marks, do those. If they don't make sense to you, don't. So x times x is x squared. X times negative 4 minus 4x minus 4x plus 16. And then the other pieces of the problem, I'm just going to go ahead and drop down. Okay. And then the last part here is to write down, right, this expression in simplified form. So we've got some like terms we can combine. So x squared. And then if I look at, let's see what I've got here. Minus 4x plus 2x, right? All those x terms can be combined. So negative 4 makes negative 8. Negative 8 plus 2 makes negative 6x. And then I've got my constant, so plus 16 minus 8 plus 3. So let's see, 16 minus 8 would be positive 8. 8 plus 3 makes 11. So after all of our lovely work here, you could simply box up this, right? X squared minus 6x plus 11. I'm just going to reinforce what we just figured out. So this is f of g of x is equal to, again, what you just found, x squared minus 6x plus 11. Ta-da, there is the answer to part A. That is a composite function. You took function, you put it inside of another function. In this case, we took the g of x function and inputted it into the f of x function. All right? But here's where you got to be careful, because part A and part B look almost the same, but the order is different. So in part A, we did f of g of x. In part B, it's g of f of x. So the order here is going to matter. Just like the order that you divide things matters, or the order you subtract matters, the order you do a composite function absolutely matters. So in this case, all right, let me change up my colors here. Let's go, I don't know, purple this time, sure. So f of x is going to go inside the g of x function. So this is going to turn into g of, and now I'm going to replace f of x with what it's equal to. So that was in the original problem, the original function, x squared plus 2x plus 3. I want to double check that. because my brain is saying, I believe it's right. Yeah, so here's my f of x function over here, and I am popping it over here, and I did copy it correctly. Okay, cool. And then the g of x function is just x minus 4. Okay. So this means I am going to set this equal to, well, g of x, remember it said x minus 4. So instead of x, I'm going to write down f of x, right? That's the expression. So x squared plus 2x plus 3. And then there was a minus 4 at the end. There's not much to do here, right? So all you need to do is to combine a couple like terms. X squared doesn't have anything like, plus 2x. And then you're just left at the end here with 3 minus 4, which would be, what is that, negative 1? Sure. So for part B, all right, part B here, you've got g of f of x is equal to x squared plus 2x minus 1. And that's it. All right, so some of these composite functions are going to get a little bit more in depth than the other ones, just depending on which way you're moving your function. So for part A, you took the g of x function and input it into f of x. And then for part B, you took the f of x function and inputted it into the g of x function. All right, so those are two composite functions. Right? These are non-numeric, which is totally fine. But that's going to be the end of this video for Note 67. Please let me know if you have any questions or concerns, and I will see you in the next one.